All right, guys. Test check. Is the volume working okay? Volume. Can you guys hear me? Cool. So we're gonna get started. I have basically a little schedule of some things I want to go over from sheet that we didn't touch base with, and then obviously you guys feel free to jump in if you do have questions about a particular topic. Once we're done with those, like I said, 4 or 5 little topics or questions. If you want to see an additional example, we can kind of make one up on the spot. Some topics are easier than others with doing that, but try to make the best of it. So I want to start with this one. This is an interesting multiple choice, and we've seen this a few times. This was number 1 from the review sheet, if you're not sure what I'm referring to. Just the zoom is takes a little while to like refocus, so just be patient with that. It's basically asking for which systems, will be phrased either positively or negatively, like which of these systems don't have the same solution, which of these systems do have the same solution as a given one. So obviously the long way to answer this would be to sit and go through and solve, each and every one here. Obviously that could take forever. A little bit more rapidly, we can answer this by simply just looking for what I call scalar multiples. So we're looking for systems that either one equation stays the same or one has been multiplied by something. So in A, notice that the top system has stayed the same, but the bottom system appears has been multiplied by 2. However, this value actually stayed the exact same. So notice how these variables changed and we kept a constant the same. So this is not a true multiple. Remember when we multiply across, when we multiply an equation by some constant, we want every term to get hit by that multiple. Okay, for B, it appears that the top equation has been multiplied by 2. All the way across, 7 became 14, -2 became -4, and 27 became 54. So that's good. The bottom equation also looks like it got multiplied by 2. This would have the exact same solutions. It's the same system. It's just been multiplied by something. What's wrong with C? Why would C? The answer is no. So it would not have the same solutions. Can anyone tell me why C would not have the same solutions? Sadiq, get out of here. It's only 720p because I'm recording on my iPhone. Not because they don't cross off. The top equation has been multiplied by 3 in seemingly 2 spots. here and here correctly. However, notice -2 stays the same. So it's, I don't even, obviously the bottom one stayed the same, but we didn't get hit with a true multiple up top. And D also works. D is something you guys would probably do if you were actually solving this. What's nice about D? It's been multiplied by 2 all the way across. It's been multiplied by -7. And why am I saying you guys would probably do this? It looks like something you would do when you're doing elimination. So if you were actually solving this, which you were asked to do in the next step, we would add these two equations together. Our x's would cancel. We'd get -25y equals -100. Divide by -25. And we get y equals 4. Now we go back to one of the originals. Let's say the 2x plus 3y. But now instead of y, we could replace it with 4. 2x plus 12 equals 22. 2x equals 10. Or x equals 5. 5, 4. Was a solution to the system. So this would obviously be a multiple choice. Just look for scalar multiples and make sure that they're applied all the way across. We saw like C, sometimes it looks like it is. Like C kind of looked good, but one thing might be missing. All right, now I'm gonna switch it up. All right, I want to take a look at this one. So take a moment. I'm just going to kind of recollect myself here. If you didn't start this one in class today, this was one of the written response questions. Take a look at it now. Make sure the camera's focused. This is bugging me out. So this is a coin system. So like I said, take a moment if you want to take a minute, maybe just to set it up, and we'll go over it together in a second. All right, so what would the first thing we want to do here, based on what this question's saying? So we have a collection of dimes and quarters. The jar has a value of 1105, and it has 70 coins inside. So both of these are very important piece of information. Also the fact that we have dimes and quarters, very important. Also notice how we're not told what variables to use. So we want to start with our let statements. Pretty obviously we'll use D and Q. D to represent the number of dimes, Q to represent the number of quarters. Okay, so if I have a total of 70 coins, I'm not incorporating any value. There's no money involved. There's no coefficients. Doesn't matter that a dime is 10 cents. That's just simply counting, hey, how many dimes do I have plus how many quarters, and that should be equal to 70. For this money equation, we want to actually incorporate how much each dime is worth. That's 10 cents. Or 0.1 D. Each quarter is 25 cents, or 0.25 Q, and that's set equal to our money amount of $11.05. And now we can move the decimal over. Not something that's required. A lot of you said that you did like this. Sometimes people don't like working with the decimals. This is basically multiplying the system by 100. If you're curious like why we're allowed to do this, just be careful. Whoa, what happened? There we go. Just be careful that you do move it over twice. So that should become 10D plus 25Q equals 1105. So now I'm going to use elimination, which means I probably don't want to touch that purple equation. I'm going to multiply the top equation that we originally had by negative 10. Our goal is to create an inverse. So I want that D to be negative. It's going to be negative 700. I get 15 quarters is equal to what is that? 405. Which means, how many quarters do I have? Quality's bad, sorry. Yeah, 27. Okay, if I know I have 27 quarters, I go back. I'd rather use this one than the money one at this point. If I had 70 altogether, and I already know 27 were quarters, that means I had 43 dimes. So obviously you want to make sure you probably say a statement of how many coins you actually had. So hey, he has 43 dimes and 27 quarters. Yeah, I'm not holding my phone, it's in the stand. Hold on. All right, cool. Choice I want to look at. I think that's there. Let me try something because this is coming out really blurry. I'm gonna just record my iPad instead. Hold on one sec, sorry. Oh, there we go. So this one I wanted to go over. This occurred on the review sheet. I know we went over in class, but this one, some of you maybe got to during the quizzes. Maybe some of you didn't. This was the one that incorporated using Lin-Reg. So we're given one equation. The trouble is with the second equation, we're not actually given what the equation is. All we're told is the actual table. So this would incorporate a linear regression on your graphing calculator. So that's going to be the stat button. And we're going to use L1 and L2 as kind of like our X and Y. Okay, so if you go into your graph, hit stat, you're going to hit enter for edit. And technically speaking, you only need 2 rows. So I'm going to type in -4, enter, and the second row, -2, enter. Over, -4.2, and -3.8. And now if you hit Stat, Calc, scroll over. So after you enter in your X and Y values, at least 2 of them, you're gonna hit Stat again, go over to Calc, you want linreg. This is an important one. Obviously, you could probably imagine if I'm going over this, not just on the review sheet, but on quizzes as well, it's probably gonna be something that you're gonna see. I'm just gonna take off Apple TV. All right. So now that we have 2 equations, we could actually solve this. So I'm going to use substitution. I'm going to replace y. One already is solved for y. It wouldn't make sense for me to use elimination. So I'm going to say 0.2x minus 3.4 equals negative 26. Okay, when we distribute there, we're going to get 1x. That's going to be minus 17 equals negative 26. That's going to be negative 6x. Push the 17 over. So really, like the whole gimmick with this, if you will, is knowing how to come up, look at a table of values, and come up with the equation for it. So once you do that, you know, you're going to get there. So if we push the 17 over, that's going to be negative 9. We divide both sides by negative 6. We get 1.5. Not a perfect value, but at the same time, not that messy of one. Okay, you need y, obviously. So I would choose this equation to plug into. If I know x is 1.5, I'm going to replace x with 1.5. Probably grab the calculator here to help me with the decimals. Do the math there. And you should get y equals negative 3.1. So to sum this up in short, something you will see tomorrow, and this was multiple choice, sorry. So choice B. Something you will see tomorrow. I'm telling you right now, you will see this. Know how to come up with an equation from a table using linear regression on your graphing calculator. And yeah, once you have it, even though there's some decimals, you might be kind of scared away here. Usually substitution is your best bet since one is in y equals form, and solve from there. Use your graphing calculator for any kind of arithmetic. You don't want to make a mistake because you didn't know how to multiply decimals together. All right. What do I want to do? Give me 1 second. Run response review. All right, so try this one if you haven't done so already. Once again, something you'll see tomorrow, maybe just kind of a weird question. Check it out. Try for, I don't know, 30 seconds, minute, and we'll go over it together. These are all posted already. Go on the website. Can't show you my cat, don't know where he is. H problem, don't worry about H problem tomorrow, Gabby. We're gonna go over a ratio problem. I would be worried about that. And coin problem. I wouldn't worry about age at all. Don't worry about age. I have 2 cats. Why is you here? Age is not on the test. Correct, sir. Cat might be upstairs. We did this in class. Some people didn't get to it. Also, we didn't get a chance to go over it. Can you guys see, is the bad for some reason? It looks like it's blurry on my screen. Miss Nicolados has a different test tomorrow. Slightly different. All right, so why is this one a little bit weird? Because we actually have to come up with the equation just given the graph first. Give me 1 second. We're gonna write down, we always do like 4 things, right? What type of line, and then where is it shaded? Now, obviously we're not graphing this, but that's gonna help us come up with the equation. So first thing, that most obvious I would say is the B value I know is 4. And what's the slope of this line? So we're looking for the rise and the run. So it looks like we're going down. So right away, so I don't forget, looks like we're going down 3 and over 1. Or simply just -3. I was gonna write the fraction, but -3 over 1 is just the slope of -3. Sorry. Move that. Okay, now what type of line is this? It was a solid line. Oop. That's not cool. So this was a solid line, and where was it shaded? It was shaded above. So let's put all this together now. My iPad is charging, so it's not gonna run out of battery. So I'm gonna say y, we know -3x plus 4. And what type of symbol should I have? Since it is solid and above, what type of symbol should I have? Since it's solid, I know it's going to have an or equal to, and since it's above, we think greater than. So that's the inequality line that's already graphed. Okay. So now, my iPad's pretty good charge. I don't need that. We're going to graph this second one. So the first thing we're going to do is get it in a nice graphing form, which would be y form. And I'm going to do subtracting x from both sides. And now I'm going to divide both sides by -2. Now when I'm dividing by, don't forget what happens to the sign. Since it's less than, it now becomes greater than. Our negative signs cancel. X over 2 is the same as 1/2 x. I like the fraction form. And 4 divided by -2 is -2. Let's write down 4 pieces of, I almost said useful information. 1/2 -2 for our y-intercept. This is a dashed or dotted line, we usually say. Remember to use pencil tomorrow, especially for these graphs. That's really annoying if you mess up. And where are we shading? Above. We did flip the sign. If you said below here during class, you forgot to flip. Okay, so on our graph, we're going to begin at -2. We're going to move 1 over 2. Up 1 over 2, down 1, back 2, down 1, back 2. This is not a solid line. So I would use like a ruler tomorrow. I'm kind of winging it here, just to indicate that it's dashed, and I'm shading above. When you shade an inequality, make sure you have lines. You're not like coloring like a kindergartner. You're just having lines coming out of the line, make sure it touches. I mean, technically this wasn't like a system question, but I guess we could label for good measure. And what's 1? I know it doesn't say also, but maybe we'll put the S, can never hurt. Where's the solution set located? Where our shadings overlap, this little area over here. And what's 1 value in the solution set? We do have to state a coordinate that works, quote unquote. 3, 2, 3, 2 works. Good. Whoever said that. Remember, don't get too cute, too close to the actual intersection point. Oftentimes, in this case too, it's like dotted. So I would not want to say like 4, 0. You had like an infinite number of points, and for some reason you chose one right on the fence, and the fence doesn't work. So don't do something like that. Choose one where you know you're safe. 3, 2 is a perfect one. I do not know how long this video is. If you want to keep asking that, go right ahead. 2, 1, 2, 1 would work. All right, number 2 written. All right, ratio 1 I wanted to go over. Very, very important. So this was like when we did it in class, we called it like cats and dogs. System word problems 3. When we did it on the review sheet, it was like the pen or marker one. Some of you, I know a lot of people didn't get to the written response today, but this was the waffle pancake one, which you probably had trouble with. Waffle pancake one. So like I said, maybe us going over that review sheet towards the end helped if you want to try to set this up. The key word here, I'll give you some hints before we go over it together. Ratio. That says 2/5 or 2/5. So remember what we saw in class on the review sheet? This ends up looking like a proportion in a sense. It's a math team question. All right. So breakfast, the number of waffles that Leslie has is 5 less than 3 times the number of pancakes. If she were to add 2 more of each type, the ratio of pancakes to waffles will be 2 to 5. So this one is actually a rare case, where it's actually harder to write it than it is to solve it. For a bonus point, no, I don't know if I want to offer that. Some of you guys might watch the show. For half a bonus point, does anyone know what show influenced this question? Half a bonus point on tomorrow's test. Not The Office. Good guess. Yeah, I figured. Breakfast Club. All right, so let's see. This is from Parks and Recreation. No one gets a free bonus point. Parks and Rec. It's on Netflix if you want to check it out. So let's start with our variables. Obviously, we'll keep it simple. We'll say let W equal the number of waffles, and let P equal the number of pancakes. Okay, so we'll start with the first sentence. The number of waffles that Leslie has is 5 less than 3 times the number of pancakes. So that can be a little tricky. So watch what I'm going to write. And now let's talk about why it's not this. Can anyone tell me why this one, I'll obviously erase it in a moment, but why is that second one incorrect? What's wrong with that second sentence? The number of waffles equation. The number of waffles that Leslie has is 5 less than 3 times the number of pancakes. So those look kind of... Yeah, G. When we say less than, it's actually sending it to the end. A lot of you guys did this with the age question on the quiz. You kind of just translate it directly. You go, oh, 5 minus 3, whatever, okay? This actually sends this behind the multiplication of 3. So that top one is actually what we want. So that's trick number 2. Less than switches the order. Good. 3. Ratio. So right away I see ratio. I'm going to use the 2/5. Think about the word proportion, which I know 7th grade you spend like 2 months doing proportions. If there's like 6th grade magnet kids in here, we're doing proportions right now. Right away, well, I know one of them is going to be 2 to 5. Pay attention to the order. This is saying pancakes to waffles. So I want to make sure my comparison starts with pancakes. Now, it's not simply just going to be P over W, because it does say that we have to add 2 more of each type. So if we were to add 2 more pancakes, and if we were to add 2 of each, right, 2 more waffles, the ratio will be 2 to 5. Think about how that makes sense for a moment, right? Notice my order, pancakes over waffles. I don't have room underneath. I had to add 2. I didn't just write like P over W. You had to add 2 more. And then the ratio will be 2 to 5. Like I said, that was really the tough part. What would be probably the best way to actually solve this? The best way to solve this would be, I would say substitution. Okay, right away, whenever I see something already solved for, I want to solve it. I want to use substitution, right? Obviously not a convenient elimination example. So notice what I did. I replaced W with 3P minus 5. I'm going to do the math there. Minus 5 plus 2 is going to be minus 3. Just to clean it up slightly. And now how do we solve a proportion? Cross multiply. 5 times P plus 2 as a whole, parentheses, equals 2 times 3P minus 3. Notice that both of those have parentheses around them because I'm multiplying the entire thing by 5 and the entire thing by 2. Distribute, you get 5P plus 10. That scared me, actually. And 6P minus 6, the 1P equals 16. And now, once we know W equals 16, excuse me, P equals 16, we use the top equation, we get 16 times 3 is 48 minus 5 is 43. She had 16 waffles. And what did you say? 43 pancakes. Now, like I said, you should notice a common trend here. Of, hey, we saw, an example on the review sheet of ratios. We see one in the written response. We saw a Lynn Reg question on the review sheet. We saw one in the quizzes. So there's with ratios, make sure that you know how to set up your proportion. Also know how to solve it after you set it up. Like I said, substitution, probably your best friend right now. This video, if you're not sure how live videos work, it's available after it's done. So if for some reason you can't be here now, you can leave. It gets posted after the fact like a normal video would. All right, and I want to look at the quizzes. The video game one, a few of you guys had questions. So check this one out. Maybe you started quizzes. This one was towards the end, so some of you guys might not have gotten, but this is a little tricky. Try this one out. It is multiple choice. Take around 40 seconds. All right. So, trick with this one, it might like scare you because it has 3 inequalities, but it is still a system, and it's really talking about vocab. So we have games and rides. So games cost $1.25 per play, so 1.25 G. Rides cost $2.75, so 2.75 R. And he brought $50. So that's an example of like we talk about vocab words sometimes. That's not a vocab word. You kind of have to understand the situation. If you have $50 on you, what symbol would you use to represent this? Obviously, what's the most you can spend? $50. You can't spend more than that. So this is actually saying less than or equal to 50. So that crosses off A and C. And now looking at the differences, let's look at B and D. Looks like the top is the same, obviously. G is greater than or equal to 10. The only difference is with R. So let's look at the rides. Let's just double check. He wants to play a minimum of 10 video games. So that makes sense. Minimum, we say greater than or equal to. And so this is where it comes down to. He wants to go on at least 10 rides. So what symbol would represent at least? Greater than or equal to. So both of these should be greater than or equal to choice D. At least, minimum, and saying, hey, you brought $50, that's really less than or equal to 50. Questions that you guys have. I can go back over the review sheet. Questions, what did I want to do? Oh, let's try this one, because on the review sheet, it worked out a little too nicely. For some reason, it worked out perfectly. How would you solve 10? So this is like, I think this was number 2 on the review sheet. How would you solve number 10? It says the graphs, blah, 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 intersect at approximately. I don't see some kind of scary answers, scary decimals. Use decimals, you don't have decimals. So we want to start here. If we're going to be graphing these anyway, we have to get both of them in Y form. So I'm going to move the 3x over and divide everybody by 4. This is basically a calculator question, literally. I'm going to leave it as 13/4. That doesn't simplify. And this one I just have to divide by, that's going to be y equals 1/3 x minus 1. So these are my 2 equations. We're going to type these into y equals, and if you have a calculator on you, might be a good idea to practice with that. Let's see if I can pull mine up on my computer. And this is going to be really chaotic. Let's try. All right, is that working? I think so. All right. So we're going to type these in. Jeez, this is really annoying. Negative 3/4 x plus 13/4 second equation was 1/3 x minus 1. Okay, notice when we hit graph, if you could see that. We're now going to see where these intersect. Did I type them in right? 1/3 x minus 1, negative 3/4 x plus 13/4. We're going to see where these intersect. And you can see we get a decimal there. It says approximately, so we could assume that we round. I don't know if you could see that. So 3.9 and around 0.3. So let's go back to, this is gonna be so zoomed in. Let's go back to the original question. We see that in choice B. So remember, that's y equals. We hit graph. If you just want to see a picture of it first. But really, the key feature here is second trace. So why did we have to do this work over here first? On a calculator, we have to type them in y equals form anyway. So you have to do a little bit of setup work here. But second trace and then option 5, the intersect feature. Remember, you do have to hit, some of you guys get stuck, but you just have to hit enter 3 times. It's going to say like guess or left bound, right bound. So don't get scared with a question like this. Right away, the second I see decimals, and since it's multiple choice anyway, am I going to actually sit and graph this? Probably not. I want to look at the review sheet for a second. Review sheet. Let's look at the KitKat example. Take a moment, whether you did the review sheet, just kind of refresh yourself on it. Maybe you noticed that you made a mistake. This will be featured tomorrow. For people that did a written response, we'll look at that maybe after this for practice. There's a similar one with candy. It's basically a system of inequalities that doesn't require graphing, but it does require kind of what you're doing with the system. This was number 8 if you'd rather look at your paper on the review sheet. And then after this, I'm going to open it up to you guys. I'm kind of running out of the major things that I wanted to hit. So if you have questions, I'll try to come up with some examples. Eight A and 8B. Well, we're going to do that in a moment. All right, so that's like column. He's not coming for some reason. Wait, hold on. Give me 1 second. Try this problem. What's up, bud? Who's that? I see. What are you doing? All right. So the KitKat example. So we have KitKats and donuts. So obviously our variables here, we'll use K and D, I suppose. K for KitKats and D for donuts. If we're not told the variables, you don't want to lose points because you didn't identify. So first, if we have a maximum of 150 altogether, that should mean K plus D is less than or equal to 150. Okay, keyword there, maximum of 150. Now my second inequality is going to involve the price. Notice it says I need at least 400 bucks. Right away, I know it's going to be greater than or equal to 400, and I want to incorporate the coefficient, $3 for a KitKat, $2.50 for a donut. Oh wait, am I saying that backwards? Yeah, sorry. I'm paying attention. KitKat's $2.50. Donut was what happened? All right. So now we're told as a follow-up in part B, the school sells 104 donuts. So that tells me in the bottom inequality, I'm going to D with 104. Okay. 3 times 104 is going to be 312. Is greater than or equal to 400, which means 2.5 KitKats greater than or equal to, subtract 312 from both sides, 88. And you might be saying, plug in up top here. Why don't you just plug in the 104 here and say 46 and close it right there? The keyword was, what's the minimum number? 46 is actually our maximum, right? So we want to know the minimum number. So that's why we're solving this greater than or equal to inequality. Both sides by 2.5. Can anyone tell me what we get? $88 divided by 3.5. It's like 30 something. Give me one sec. 35.2. Thank you, whoever said that. Okay, so this is really important. So what's the answer? Okay, great, 35.2. Obviously, we can't sell like decimal packages here, candies. So you really is. Do we want to say 35? Or do we want to answer it as 36? Sorry. So let's go through the thought process here. This is saying K is greater than or equal to 35.2. So if I say 35, I'm not going to be accomplishing that goal. So even though mathematically it doesn't round, our answer here is actually 36 KitKats. Okay, and like we said earlier, your first instinct with a question like this might be just to plug in kind of the quote-unquote easier of the two, the one without money, and say, oh, it's 46. The key word was, what's the least number of KitKats? So this equation isn't going to tell you the least number. That's going to be the most. So we plugged into the money one, if you will. All right. One last one I want to look at. Flip to the back of your review sheet. If you didn't get a chance to do it, I'll give you a minute to maybe even just, if you did do it, look it over, make sure you're comfortable. This would obviously probably be the very last tomorrow, as a hint. Very back one on the review sheet, try it out. What's up, Mook? The goat himself. He was just eating. All right. So last one, and then I'll just, after this, I'm just gonna go over some last minute tips and then last minute questions, and then I know I have to run, and a lot of you guys have to run as well. So we're setting up a system first. So we have, obviously with this question, I'm gonna tell you to use X and Y because you're gonna be, just to avoid any confusion there. So we're gonna leave that out of the equation, no pun intended. We have 200 seats. There's like cat hair on my iPad now. There's 200 seats. So X plus Y should be less than or equal to 200. Right, that's another example of, hey, there's no real vocab word there, but if you have 200 seats, just be aware that you really have less than or equal to 200. Now the second one is going to involve our prices. So parent tickets were $12.50. Student tickets are $625. To make at least $1,500. So what would be the best idea for how we should graph this? Notice my symbols. All right, we talked about, hey, I have 200 tickets, less than or equal to. At least $1,500, greater than or equal to. So I know it was good to go. How would you graph this? Not you anymore. I would say standard form. That's what I tried to mention in class. So we're actually going to use intercepts here. So I know 200 and 200 right away. Okay, I know this is going to be a solid line. And since it's saying less than or equal to, I know it's going to be shaded less than, below. So check my graph. 200, 200. Use a ruler tomorrow. And we're shading, you said below, right? Below. Don't go too nuts with these. It is one quadrant. You don't have to go too crazy. Right away, so you don't forget, let's label. You don't want to lose a silly point on like a 4-point question for labeling. Even the axes, child and parent. Okay, second one. This is where it would really be helpful. The top one wouldn't be too bad if you got it in Y form. But with the top one, we want to find our intercepts by pretending the other variable isn't there. So for x, for the x-intercept, pretend it didn't say 6.25y, right? And you just solve this by dividing 1,500 by 5. The x-intercept would be 120. The y-intercept, oh shoot, now I can't erase this. Okay. Pretend x isn't there. Right, when I'm saying pretend it's not there, that's because it's really a 0. The pretend thing just kind of helps you calculate it quickly. Divide 1,500 by 6.25, we get 240. This is going to be solid, but above. Why is it above? It says greater than or equal to. All right, so 120 x, 240 y, straight line. Probably shouldn't have labeled over there. And this is above. I'm not going to go crazy over here because I know it's not a solution anyway. You can see where are they overlapping? Right in this little slice of pizza on the bottom here. I don't have to label. I can if I want to. Technically, labeling just one is fine. My solution set might say something like label it with an S. It does. Is right here. It's where the shadings overlap one another. So this is the shaded region for not just one inequality, but for both. Yeah, if you want, can you just shade where they're overlapping? If you want to make it like kind of fancy, people have trouble seeing that. That's what I'm going over how to, where he's talking about. Right there. So was he correct? He's saying that this is a possible solution. I think everyone here can answer that. Right? It's not in the, it's only in the blue shaded region, not the purple. It doesn't say. You don't want to just do this. No, ... It says explain, so you don't want to say, no, it's not in the shaded region for both. Something like that. All right. So that's everything I wanted to go over. We spoke about just a quick recap if you came late, if you missed stuff. With a table question, the question where there's like a table of values and then a system. How can you answer that? The trick is lin-reg. Lin-reg is going to give you the equation of the table. And then from there, you guys know how to solve systems, hopefully, using elimination or substitution. Probably substitution, because this is going to give you an equation in y equals form. We talked about the ratio question. Hey, the ratio of this to that. Right away, I would set up a proportion. They're going to give you I'm going to give you a ratio. So if I say, hey, the ratio is 3 to 5. The ratio of whatever, pencils to markers, if you add 7 is 3 to 5. So if I add 7 of each, pencils to markers is 3 to 5. And then you're going to have a second equation that obviously probably says something like this. So you'd want to either use substitution probably, not something that you'd want to use elimination with. Also remember how to solve proportions. 7th grade throwback. Cross multiply. One thing that we didn't talk about in this video, in this live, if you will, using matrices. That wasn't. So a good example occurs, I made like 2 of them in quizzes. Let's see the ice cream one. So do this. Grab a calculator if you have, hopefully you have a calculator at this point. Try number 5. Using matrices. Now, why am I telling you to use matrices? Tomorrow's test might be a little bit on the longer side if you're taking 20 minutes to solve a multiple choice question like this, right? So that's what I'm saying. Obviously, you want to set this up and everything, but to save some time, know how matrices can be a major tip. You don't need to label the axes for that graph in question. They had an X and Y there. You could label them with the title. So if it said like, what was it, students and adults? All right, so we want to set this up first, right? We can't just type in a matrix from like a word problem. So it looks like we're talking about small and that tells me S plus L is 50. And then small cones are 310. My S's always look like 5s, and larges are 490. L, and you made $180.20. So there's a matrix video. I'd recommend watching it. Like I said, this is a very, very useful tip for tomorrow. My concern is about people running out of time. Unfortunately, with the test, I can't say, hey, take 4 hours and finish this. So if you do want to be able to finish, I would recommend paying attention right now. Notice how my system, the video talks about this a lot. What do I mean by lined up? Notice how S corresponds to S and L corresponds to L. My matrix is going to be all scrambled up if that's not the case. Okay, my equal signs and then some number on the right. If I switch like L and S in the second one, then all of a sudden it doesn't make sense anymore. So let's try this. Using the matrices. Obviously, you could do elimination. Like I said, this might just be a time concern. So, does that work? Okay, so we're going to go into second, x to the negative 1. See, I already have a 2 by 3 there. We have to edit it. Okay. Great. All right, so we're going to type in, our system was S plus L, which means 1S plus 1L is 50, equals 50. A matrix is pretty much just using the pure numbers from the system, no symbols, no variables. In my second equation, 0.1S, remember it was important that we started with S in both. 4.9 L, and that was equal to 120, or 180.2, sorry. Okay, at this point, you're gonna hit second, quit. I'll zoom out a little bit. Okay, we're gonna go back into there, second X first, edit, math. You could scroll down, I scroll up, we want RREF. RREF, that stands for Reduced Row Echelon Form. We're gonna select that. Now it's pretty much saying like, what do you want me to do? All right, that's the function of what? So we're gonna go back in one more time. We only have one matrix. Hey, can you do this for matrix A? Sure. Now what does that mean? Remember how we said that this was S and this was L. So this top line is saying 1S plus no L's is 36. And this one is saying 0 smalls and 1 large is 14. So that tells me my answer. I know that there are 36 small and 14 large. Like I said, this saves you the effort of doing elimination. Now, how many large cones? Oh, 14. Okay, I very, very highly recommend if you have, a multiple choice tomorrow, other than guess and check, because that will take you even longer. Don't sit and do, 10 minutes worth of work and double check it and graph it and elimination. Using matrices would be my #1 tip for tomorrow. Something that I've spent a lot of time showing you guys. Like I said, it's like a pre-calc college level math concept, but can be very, very helpful. All right. Yeah. Any last minute questions from you guys? That's pretty much everything. I'm out of breath. Questions, something really quick. Question about the test. Answers for number 1. Don't hate? No. What's Kahoot? We do quizzes. I'm not a big Kahoot guy anymore. Kahoot sold out. You gotta like pay for a lot of their things now. I can make the quizzes live if you want to do that for some reason. I'll post that on the website. So as I'm waiting for questions here, remember on the website, we're only halfway through the year. Maybe some people will figure this out. But on the website, not homework, but exam review has a lot of stuff. Has all the answer keys for the... I do have the Kahoot soundtrack. Has the quizzes review. Like I said, I'll post the game if for some reason you're like, hey, I want to play a game tonight. I just have it as a PDF. It has that answer sheet, and it has the written response answer sheet. The picture is kind of taped on the wall today. So exam review on the website has all those resources. You too, buddy. Last minute questions, 2-minute warning. Anyone want to know the answer to number 1? Lynn Reg? Again? Oh my God. So Lynn Reg was stat. I guess it would be easier for my... Okay, so I don't have like an example to type in, but I'll just go over the buttons. So Lynn Reg was stat, edit, and then you treat L1. So this is like the example we did in the very beginning of the video if you weren't here. We're treating L1 like the X value of whatever table we're given, and we're treating L2 like the Y table. Now you don't need to, if it's a table of like 10 values, a line is determined by, remember, just 2 points. So you type in the first 2. Doesn't matter after that. You can. We talked about saving time tomorrow. Probably not a good idea. Let me zoom out. Once you have that in there, you hit stat, calc. Lynn Reg is option 4. So I hit 4, you're gonna hit enter a few times, and that gives you the equation. You just have to actually piece it together yourself. So you know that equation, whatever it might be, obviously the question, like, so that for that one that we did earlier, the question becomes a lot simpler because now you're going, oh, let me just use substitution. So a lot of you guys got confused. I saw a lot of blanks for whatever that was, 6, 5, number 5 on the review sheet. I saw a lot of blanks. Once you come up with the equation, I think we'd all feel a lot more comfortable. So that was the trick or gimmick for that one. Good question. Ratio one, know how to do, set up a proportion. Coins, do this for your coins. So dimes, 0.1D. Nickels, don't do that. What's wrong with that for nickels? Right, it's not 50 cents. So we should say 0.05 N. Quarters, you're gonna say 0.25 Q. So just know how to set up your coin systems, right? It's only gonna be 2 of them at a time. So it'll be like dimes and quarters. Know how to get rid of the decimals if you want. You multiply everything by 100, which moves all the decimals 2 places. So the dimes becomes 10, not just 1. Any last minute questions? What am I forgetting? Let me look at the test, actually. I'm gonna pull up the test on my computer. You guys can't see it. Let me see. Went over a lot of similar examples. I think if you date with going over the review sheet, paying attention to all the little things I talked about in this video, you're gonna do really well tomorrow. Like I said, time is a little bit of a concern. So make sure you're working appropriately, effectively, and efficiently. You know, if you're still on question 2 on the multiple choice and we're 20 minutes in, hate to break it to you, but you know, you got to work a little bit faster. That one where I think we did the KitKats and donuts. Know if you get an answer like this, or was it KitKats, whatever. Even though mathematically this might not round, right? We said, oh, how many donuts do they have to sell? We talked about it being 21 donuts. Hi. Hi, Grandma and Uncle. We talked about that. And yeah, little things, labeling your systems, making sure your answers are clear, setting up your ratio, let statements if it doesn't say what variables to use, knowing to flip the sign if you divide by a negative with inequalities. Know that at least means, know the difference between at least and at most. Know that minimum really means greater than or equal to. Maximum really means less than or equal to. Yeah. Scalar multiples. So if I say, obviously this wouldn't be like a real multiple choice, but like, hey, will these have the same solution? I don't even know if this system does have a solution. So like this and this. Right, and let's say the bottom one stays the same. Right away, I notice this is times 2, but the 8 stayed the same. So the whole thing didn't get multiplied by 2. I know they won't have the same solution. So you're checking for scalar multiples and that they've been applied all the way across. That would probably be multiple choice. So you kind of go through them, see which one doesn't fit or which one does fit if it's asking for that. If you're having trouble with the matrices, I went over it earlier. There's a matrix video on my, it's posted on YouTube. It's also featured under exam review, the link for it if you want to watch it there. Math team questions. All right, guys. If you watched, thank you. Hopefully you got something out of this. Good luck, man. I don't know about it for you. Yeah. Thank you all for watching. Don't stay up till 3 in the morning studying tonight, but definitely look over some of the exam review stuff. Watch the video of the matrices stuff. Very useful. And have a great night. Take care, guys.